Okay, good.
Yeah.
So conceptually, BIMStorm has been about bringing together a lot of different players and tools, creating a neutral environment where we can share data and resources, um, both proprietary and open source and whatever. It really doesn't matter. We're inserting actual project data into it too, and the actual guidelines from like VA that we guided them towards building up a web service access to their data. So this is live VA data, for example, that's coming in from project requirements or standards. And this has been online for a while as well too. Owner data driving into models from the early design point of view. And having many applications plug into that. So we've already had interaction with SketchUp, obviously, through Devin and others. But jumping ahead to the work that you were interested in, let's see, right here. Okay. So with my Building Smart Alliance hat on, I'm chair of thought leadership, and Van Woods, who's on the board and on the Corps of Engineers out of the Seattle district, encouraged us to see what we can open source and drive some discussion in the industry about what's going on. We obviously have our own proprietary tools called the Onuma system that's been in the cloud for many years, with web services, with all that stuff running for many years. We've opened up a Trello board where we're posting information about what we're doing with these projects, these open source projects. We've built a prototype application, a leaflet application, a viewer that reads data in a GIS format, and we extended that to support BIM geometry, so we can click on a map and pull up the floor plan of a building, for example, with data associated with it. And I think Thomas might show a little bit more of that live. We've opened up the GitHub repository on the Building Smart Alliance GitHub. We're calling it a prototype project. And the reason we're calling it a prototype project is, as many of you know, the Building Smart International and Building Smart Alliance and IFC standards have a certain process that they need to go through, and vetting and all that stuff. We said, what happens if we think in terms of building something really in an agile way quickly and just putting it out there and seeing what could happen with it. So one of the three tools is called the Bimcloud. Thomas, maybe you could do a better job of explaining this than me. So why don't you go ahead? It's no geometry in this one. It's basically just data. Yeah, go ahead.
Right. So it was really, it originated from a challenge that Vane from the Corps of Engineers gave us and said, we really I would like to see something where we have a simple database on a web server where we can store the data, where we can get the data from a Kobe file, for example, into that and generate a web service out of that. So we took that challenge and used Web2Py framework to create this. It was done in a couple of days. Importer for Kobe file and the Corps of Engineers workbook. They have something that is a little bit similar, but the Corps of Engineers decided to not normalize the data between type and components, instances and types, and so theirs is more of a flat version, simpler for users to input. That was one of the concerns, that it was too complex to input the data into Kobe, so that's why they created this. So we created this importer, and we really just use Web2Py standard modules to do this, to import that data and create an SQLite database. So for each project, each file that gets imported generates a SQLite database, which then is available as a web service. I don't know if you want to get into this now for showing actually the live version of it, but basically all it does is a RESTful web service. It generates that so that it can be used by a front-end application. And that's the other part that we built. We built basically a very small front-end application that uses that web service for asset management. So we said, okay, now we have assets in that SQLite database from a Kobe file, and now we create an asset tracking front-end app that uses exactly that web service. And the same thing there, we used Web2Py. This one is even simpler, basically, the application. what you get is the complete list of all the assets in that COBie file, and then you can edit, you can add assets, you can modify them, or you can delete assets, and always at the bottom right you actually see the web service calls that are being made, the RESTful web service calls that are being made. So you can, as a developer, you can see what's actually going on with those calls, which service is used, and in the end, you can then export again that COBie file that you imported originally with the newly updated data. So it's all just a very quick. The whole thing was probably a couple of days that we built this, and this could, of course, be built out further. What we used here is a simple JSON format that fit our needs. We later developed further in that leaflet application that Kimon was talking about. We originally thought of creating a JSON format that similar to the GeoJSON, basically an extension to the GeoJSON format for buildings, for building interiors. Now, after much thought and all that, we basically came back to the situation that we said, okay, no, let's go just straightforward GeoJSON, because then other applications can use it as well. There are certain limitations. GeoJSON does not allow any kind of curves, just like a lot of GIS applications don't have curves. They break down the curve into segments. So that's one part of the challenge. The other is that a building has a lot more attributes that are non-geometric, just like what you showed with this Bimcloud and that web service. There's a lot of information in a COBie file is all non-geometric, and so we need to extend the GeoJSON format to also include more of those attributes. The leaflet application is really working extremely well, and Kimon, I don't know if I should show it or if you want to show it. It's you might know leaflet as it's a open source library. GeoJSON or not just GeoJSON, just a mapping library, and we use that together with web services that we created from inside Onuma. So these are now we can load a building. This is the new biotech building from Solano. This is an actual building that's being built right now in construction. And you can load components of an individual space, or you can load all of them together. You can look at this in 3D on our iPad app, things like that. So there's connections here to do that. But at least you start to get the information that is actually in that building. You get that when you click on the individual piece of equipment. So the diffusers or whatever, you start to get that information. This one has currently limited. I mean, the GeoJSON web service that we created in Onuma, the big challenge was building information. Kimon just opened now a typical that GeoJSON response from the Onuma server. So the Onuma server is serving as a Bimcloud server here, and we have now limited, but the limited attributes in here that we get out of the GeoJSON response. But the interesting thing here is that we, on the fly, we convert local coordinates to global coordinates. As you know, almost all BIM applications work with, or all of them actually work with local coordinates, Revit and all of those. And but we created here the web service that converts those to global coordinates, so we can use it directly in GeoJSON and Leaflet. And these are open source, so yeah, you can go to GitHub. The Leaflet application is in the Building Smart Alliance GitHub. The BIM plan is the leaflet, right? So we had one actually developer already forking it and cleaning up some of our code. He did a very nice job separating more of the ours was fast development, and we had JavaScript inside in the header in the top part of the file, and he separated them all nicely into their own files, the CSS and JavaScript all in the separate files. So he did a very nice job, and we pulled it back in. His input. So this is something that we can keep on developing on this BIM plan. There's opportunities here. One thing that would be interesting, we have a format, our free plugin in Revit generates a BIM XML file that is local coordinates. So that's an XML format. And it would be beautiful to have, for example, a translator from that BIM XML format into the GeoJSON format, so that you wouldn't, I mean, that's almost against our own business interests, because you could start using that directly to generate the JSON files for the leaflet viewer. That would be one thing. We could start adding more attributes, so you could start modifying data from within leaflet. So if we can at the back end, we can create GeoJSON web service, expand that to have more data, and somebody at the front end could use the leaflet viewer open source project to create updates, so that we can update the data, post back to the Onuma server. The cloud server, of course, there's a lot of opportunities there. If you have somebody that is interested in front-end applications, one could come up with many different front-end applications. This is now asset tracking. One could create a work order system front-end applications to attach to this, or I mean, to use these web services, or one could use barcode scanners to start collecting information. So there's a lot of interesting small pieces that could be added. Obviously, this front-end application doesn't need the Web to Pi here is just the way we did it, but you could build this front-end application in any other framework. Of course, it's just simply requesting API. And right now, we actually have to say for all of these, we have only certain projects that we open up. Basically, all the stuff that we're using for this BIMStorm, because we did not implement authentication yet. So we eventually, of course, we have to add OAuth to probably authentication into this for these applications. Right now, it's all when you import the Kobe file, it's pretty easy, because you generate a GUID which is so unique that nobody else could really guess it. So that's almost security already there. But eventually, we have to build in authentication.
And one point about these three things that we showed, so the Bimcloud and the asset tracking has no geometry other than it's tracking space information, whatever, but not the actual geometry. And that was intentional to see how can we use BIM data without geometry and still get to this point rapidly. And even the BIM plan, we actually coined the term minimum viable BIM. We're saying what's the minimum that we need to get the maximum data. Because we've been working with detailed BIM for many, many years. We do all the 3D stuff and everything, which is very important. But we're saying from an industry perspective, especially this work that we just got off the webinar with this campus in Solano, the facility management team, in that case, they don't even want to see the detailed BIM. They want to just get to their facility data. So it depends on what the use case is. We're saying it's important not to say everything has to be in the full-blown BIM. There's ways to actually, through web services, create simple applications on top of that data.
Right. The minimum viable BIM is also important because of the data load, of course. You want to be able to access it fast and easy on mobile phones and mobile application tools. So I think, yeah, that's an important part. This leaflet plane is really extremely simple format.
And the reason that we even got this fast here is because obviously we have the Onuma system in the background driving the geometry. So in this case, it's using the Onuma server Bimcloud to feed into Leaflet. In the other ones, it's not the Onuma server. We're just calling it Bimcloud. It's just a separate server
But that's another thing here. Another thing that we could do. Somebody could work on to actually combine those two to to call up, because the SQLite database already now generates the structure exactly like what we talk about in COBie, but at the same time it also it's that FedIFM that we've worked on at some point a couple of years ago, that structure, a data structure for building data that is quite simple, but is really what is at the basis of every single building, is that kind of basic structure. And then you can start to plug in other information from the outside into that basic structure. So the SQLite database that is generated here actually already has the fields that are needed for the geometry as well. So you could easily create a request web service that pulls in the data from geometry data that could then and then you could actually use this web service to connect to the leaflet. So there's a lot of floating pieces here that could be interesting.